All right, so how's this is gonna go is that we're gonna have like a bunch of problems we're gonna give you guys. I'm gonna start writing them on the board, and we're gonna give you guys like 2 minutes to do each problem. All right, so I'm gonna start with basic functions. So number 8. So given the following function, how much can I start with? Let's see. Function. All right, so this is a function called foo, and I'm calling it my main. So pretend that like I have my main already written. What is the result of this function? And this shouldn't be too bad if you know like what happens when I do an function call. 6. Yeah, you can immediately see that like right off the bat. So in this function call, what are my arguments to the function? My actual arguments. My arguments are 2 and 4, but what are A and B?
They're your variables.
Yeah, so when I'm making a function header, I first start by declaring the return type of this function, like just name the function almost like a variable, and then I provide a list of parameters. So this function is expecting 2 integer parameters, and I supply 2 integer arguments in the function call. So that's not too bad. And so something a little bit more advanced is default parameters. So the second question, what does this function call evaluate to? Which is side, sorry.
Isn't it just 3 because the second one is the same 7? Oh, you have 7 up here?
Yeah, notice the change.
The 10?
Yeah, so it is actually 10. So does anyone know why?
B is set to 7.
Yeah, B is actually set to 7. If I don't provide B, it's going to be using something called a default parameter. So if I don't provide this an argument for this parameter, it's going to use its default value. Yeah.
So say if it wasn't B equals 7, but you just put foo 3.
So if it wasn't B equals 7, so what does this do?
Error.
Yeah, this is an error. I don't provide enough arguments. And there's no default parameter for B, so this isn't matching the functions we defined. So that's an error. Which type of error is that? Yeah, it's a syntax error. So any more questions on like basic function calls? So what can I do? So what happens when I do this?
With the 3? With the foo 3?
Yeah.
Is it still 3?
Is it? So I gave A a default parameter. Yeah, it's still an error. So you caught that real quickly. So this is actually pretty ambiguous. So I can only assign default parameters to the functions for parameters that come at the end. This is legal because this isn't really ambiguous. Like I can call foo like this, and it'll use the default parameters 3 for A and 3 for B. Does everyone get this? So, but if I have this, it doesn't really make sense. So something like this would be pretty ambiguous still. So any questions? All right, so I guess we'll move on to the next. Oh, quick question.
So basically the arguments have to correspond to the parameters in order?
Yeah, so they have to correspond to the arguments in order, and they have to have the same type to be matched. Then I can correctly call the function. So, right. So I'll let Michael. So, right. So I guess I'll come up with something real quick. So, reference parameters. So let's say that I have some integer a in my main, and it's called as 3. So out of these function calls, there's 4 of them. Which one of these are legal? So out of a, b, c, and d, and why are they legal?
Illegal or legal?
So I guess you can pick out the legal ones or the illegal ones. It's still solving the same problem. B and D are the only ones that are legal or legal? Yeah, they're the only ones that are legal. B and D are the only ones that are legal. Why? So like they actually don't match this type. This type that we're actually expecting is an integer reference. So I'm able to get an integer reference of any variable, of any integer variable, but I can't get a reference to some value, some literal value. So yeah, so this one would be an error, and C would be an error, but B and D would be okay because if I'm expecting an integer, I can pass in either a value or a variable. So if I pass in by value, I can pass in either a integer variable or integer literal, like 2. That 2. So any questions on this?
Right. Here I have a function called foo. It accepts 2 parameters. One is a double reference, so reference to a double called b, and another is just an integer e. Okay. This is basically a power function, the one that you may have used before. It takes in a base b and an exponent e. It changes b to be b to the e. So if I have if my base is 2 and my exponent is 3, then 2 to the 3 is 8. Okay, so that would be an example. So you have 2 integers in your code. A equals 4 and B equals 2. All right. You call foo on A and B. What is the value of this expression? What will be printed to the screen? Take your time. The question is, what is the value of foo A B? Yeah. What is the output?
So for these problems, it really helps to just draw out what's going on. So drawing out like, hey, what variables are in main and what are the values, and the same thing with foo. And notice anything to do with references, it's probably helpful to draw, hey, what is this a reference to? We cover these a lot because these are usually big parts of the test. And the big parts of the test we will get from. Alright.
The answer.
64?
4.
I'm not sure that's not the answer.
Close. That's a power of 4. Not 5. The answer is
8.
16. It should be 16 because what did it do?
Yeah, so you go.
Oh, yeah. Alright, the answer is 16. Alright, and here's why. Okay, so in main we have two variables, A and B. These are in main. Okay? Alright. So A, we give an initial value of 4. Okay. B, we give an initial value of 2. Alright, that's the first step. Then we call this function foo on A and B in that order. So foo has two variables. One is B and the other is E. Alright? But the thing about B is that it's passed by reference. So it has the location of whichever argument is specified. So if I say A as my argument, right? So it has to, a variable has to be passed in, not an expression or a literal. It has to be a variable. Okay? Passing in A to this function will make B a reference to A. Alright? So whenever we change B inside foo, the changes will be reflected in A. Alright? And E is just an integer that gets passed in, just regularly. A value is copied over into E, and that value is 2. Alright? So now we're going to run through the code. We have another variable, origin. Okay, it's inside foo. And it's set to the original value of B, and B is just a reference to A. So that value is 4. Alright? And then we're going to have another value I. It's going to start at 0, and it's going to go all the way until it's equal to E, because when I equals E, this expression is false, and we break out of the for loop. So we have I next to it. Okay. So we're starting I at 0, right? So we're going to ask, is 0 less than 2? That answer is true. So we're going to do this line right here. B times equals origin. You may have seen the syntax before. It basically is equivalent to B equals B times origin. Okay, they are exactly the same. This is just shorthand for it, so you don't have to rewrite the variable name on the left twice. Okay. So B times origin in this case. So B is 4 times origin, which is 4. So 4 times 4 is, I think I did get that wrong. Yeah, 2. 16. Might have been, well, yeah, it is 16. So, but 16 goes into B, and B is located here, right? So the changes in B get reflected in A. So A is now 16. Oh yeah, and you were correct, I think, in saying 64.
Oh.
I thought it was to the second. It's actually to the fifth. So yeah, you're right. All right, so I gets incremented. It's now 1. Okay. And then we test it again. Is 1 less than 2? Yes. So we get to do this again. B times origin, so 16 times 4, 64. That change gets reflected in A because B is a reference to A, right? And the value is 64, right? And then we're going to return origin, which is 4. Yeah, I thought this said, but we're just going to just return B. Change the problem just a little bit, because. All right, and it returns the value that is in A, actually,
So
because.
the original question, the answer was 4, and to return B, the answer is 64.
Yes.
Yeah, because this question makes more sense because
Right.
we already
Yeah.
know the value of origin. So.
Okay. Any questions on reference parameters? Yes.
You know in the foo parameter, it calls for a double reference, but then
Yes.
in main it says int.
Whoops. It will. Won't it?
So it actually does type conversion for those.
Okay.
For even references, it does type conversion to a double. It treats it as a double. And again, I can do that from a double to an integer is 2 doubles. So, I can if I try to cast a double into an integer, what happens?
A double into an integer?
Yeah.
Leave that in there.
So
I thought you can only do an integer into a double.
So like, let's say I have a double D is equal to 3.14. What happens? So what is actually stored in D?
3.
Yeah, it's 3. So that that typecast is valid. That's double. I'm able to fit that integer or that double into integer, but I truncate that double. I lose information. So it could still be done. Any other questions? So, okay.
Alright,
Sorry.
so this is, again, with references. What is the output of this program?
So yeah, that one looks a little bit more intensive. There's like
Yeah.
a few functions going on, so you have to really be sure you're like keeping track of like who's who.
Yeah.
You might notice that like usually when we implement swap, we take in both parameters in by reference, but this ain't. So you might need to watch out for that. So
Alright, any ideas?
That one's hard.
Anybody got like think they have an idea of any of the answers?
I know.
It's just very, very valuable.
So you can more time?
Yeah, give him a little bit more.
Alright.
2 minutes, 1.5 minutes. Sorry. 1 minute.
what is that?
So any idea?
Oh
No?
my god.
Still nothing? Okay, I'll just like work through it.
Okay.
So it starts with this line. So it starts here. So this is the first line in main. So this is what runs with. So it says a equal to 1, b equal to 2, c equal to 3. And then the next thing it starts is it calls int r equals to a, b, c. So it goes to here now. But you need to keep in mind which ones are references. So a and b or b and c are references. So just to indicate that they're references, so that we know how these values interact in this. And then it calls swap a, b. So in this, then a and b, or a is a reference, but b is not. So what does that tell you about this? Since b isn't a reference, what's not going to happen to b after this function? What?
It's not going to change.
Yeah, b is going to stay the same after this function call, but a is going to change, right? So what is a going to change to?
I got 2. That's my answer.
Yeah, so c equals a, and then a equals b. So b is 2, but a is 1, so now it's now 2. Right, so
Crazy,
Maybe
crazy.
we can write it out kind of like.
Oh, yeah,
maybe
could you write it out
include
for
so we can follow it,
Yeah.
the arrows, 'cause this is very confusing.
so
Thank you, I'm sorry.
so this is main, and then also for this level of foo, at the very start of foo, this is its state, right?
Okay, so then the food's also the same.
So yeah, at the start of foo. And then after this first swap. So in this, there's a, b, and c, right? So a its value isn't going to, or a's value changes, but b's does not. So after this, a is equal to 2, and b is equal to 2, c is still equal to 3. And then after this one, swap c and a. Which value gets changed from this one? Yeah, c's value is going to get changed. What is c's value going to change to? Yeah. So now all 3 values are equal to 2, right? So then it gets down to here and returns a plus b plus c. Yeah. So it's now going back to main. So
2, 2, 2, 6.
so it's a equals 2. Or no, it's not. What is a equal to? Now we're back in main. So what is a equal to? What? What is a equal to?
1.
Yeah, 1. Why is it equal to 1? Yeah, because it wasn't passed by reference. So a's value isn't going to change, because it was just the value of what it was, which was 1 at that time, is what's changed. Okay, so b is equal to 2, right?
2.
And then c?
Still 2.
Yeah. And what is r?
5. Oh, no.
No. So remember what the state was when we got to this one, right? So after these 2 swaps, what was our state from this table?
Oh, 6.
Yeah, 6.
Okay.
So yeah, that's what it counts, right? Does that make sense? Any questions?
I didn't get why the swap C, A is going to be 2 and 2.
Well, a's value got changed to 2 from this one, right? So because a is equal to b here, a's value changes to 2. Does that make sense?
Yeah.
and then swap C to A. So C's value is now equal to B in the function call, which is A. Does that make sense? So A was 2 from this one, so now C is also 2. Any other questions?
So we're going to go on and to this next set of problems I like to call header discovery. So a possible task you can be given on the exam is like, hey, given these function definitions, what is the best possible header, like function header, to give these? So you can think of these as bodies. What's the best head to choose for these functions? So I have two function definitions right here. So one of them does something and another one does something else. I want you to tell me what is the best, what is the best function header that makes sense? So first off, what does a function header need? I've said this a bunch of times. So there are a few main components. Yeah, first off is the type of data it returns, the return type. So one, return type. What's the second thing? So there's actually something like right before the thing you're talking about. So like, yeah, so the name of the actual function. It's almost like variables, they need to have a name, which we can call it. So name. And three? Yeah, so a bunch of parameters this function accepts. We can call this a parameter list. So parameter list. So I want you guys to find, I'll give you guys like 2 minutes for the first one, and then we'll confirm the answers. And then we're going to go on to the second one. So I want you guys to find the best possible return type, name, and parameter list for this function. That's best for this function definition. So is that clear? All right, cool.
What's that character after S before you employ?
Oh, that's less than or equal to n. So I should probably make that clear. S less than or equal to n. So we say plus plus s. So just think about like what this function does for a little bit. The probably most obvious thing is the return time. So you can probably do that first. It's been 30 minutes.
So if for sure you're gonna post actually what you've written down in the sample problems, so you probably don't need to write them all down, but I know that you're not actually gonna post them when you're reviewing.
We're not going to post these specific problems. We're probably just make
Right,
emails.
so then we can write them.
Yeah. Some of these are kind of altered. We might be able to post them. So
Might is too scary.
yeah, it's too scary. So
Captain and have breakfast.
let's go down writing code. Yes. Just my okay, I'm gonna be erasing this. Okay, so first things first. What is going to be my return type for this function? Yeah, so this one's not that, it's pretty obvious. So like, hey, I have an integer x, and then later on in the function I do some magic stuff, then I return x. And x is a type int, so my return type is probably a type int. So first off, my return type is int. Okay, cool. So this one's probably a little bit more hard to think about. It's probably one of the hardest what's an appropriate function name for this? So what does it do? Like what the heck does it do? Yeah, something like that. So like I notice that, hey, all this is doing is like summing up these values, 1 plus 2 plus 3, up until some n, I guess. Yeah, we can call this count or sum. So what do you guys think? Sum's probably better. It's more of like a, let's call it arithmetic sum. So sum. And then the last piece of this puzzle is the parameter list. So what's going to be my parameter list? Yeah.
Types.
So am I going to pass in two parameters or one parameter? Yeah. So there's only going to be one parameter, and one thing you can notice is like, where the heck did this n pop up from? So it's the only thing we don't define in our function. So it must be some parameter. Like the user must pass it in somewhere. And what's going to be the type of this? Yeah, it can be some integer. So like I'm comparing it against some integer. So it must be some integer. Okay, so int. All right, so this is a nice function. It's complete now. Has a head. That's the one that's kind of a little bit easy. So now the question is, what's a good header for this function? That's the return type. That's one piece of it. So I'll give you guys a minute to do this one. It's not too much to write. It's just like. So again, the thing to keep in mind is, what do I return? This is probably the hardest part. What is a good name for this, and what's my parameter list? Yeah, that's true.
Yeah.
So this is a little bit ambiguous, right? So these can be these can be strings, these can be doubles, some character. Yeah, they can be characters too. You can compare characters. So this is only limited to things you can compare. They're of the same type. So I'm going to make it easier and just say that these two are ints. A and B are integers. Where A and B are ints. But are they just ints? Like, is the parameter list just ints? Alright, so looks like everyone has an idea how to do this. So first off, what's my return type?
Void.
Yeah, void. So like it's possible for a function to just not return anything, and those we call procedures. Functions that return void, nothing. So it goes here, first void, and then a name. So this one's a little bit tricky too. So what's the only thing I do? Swap. If A is greater. So like something like swap if greater works well, right? Kind of catchy, no, it's not. So I know swap if greater. Yeah, and what's going to be my parameters? Yep. So yeah, I'm going to explain that for a second. So what does this function do if I have my parameters like this?
It's not gonna go back, it's not gonna be swapped and get it back to the beginning.
A is still gonna be A, B is still gonna be.
Yeah, so like no matter what I pass in, let's say I pass in like where A is equal to 3 and B is equal to 4. At the end of this function, nothing's going to change to the outside variables. It's not going to, it has no effect on the world. So it makes sense. It only makes sense if I pass these in by reference. So now there's some actual effect going on. So does everyone understand so far? So like if I didn't pass it in by reference, none of these variables will be changed, and it doesn't return anything. So it's not really doing anything. Okay, and one last thing. So this is correct. What do you mean if I do this?
Then it's not a point.
Yeah, then this is not a void.
It's a name swap with greater.
Swap it greater. What if I have this now? What if it doesn't change anything? What does this function do now?
Doesn't return A.
It returns A only if, but what happens in this function?
Oh, but it swaps the value change.
Yeah, so this actually, you can actually think like really quickly, hey, if A is bigger than B, it's going to swap it. It's going to become the smallest no matter what. So this is actually a function that gets the minimum of A and B, and doesn't actually alter the parameters I pass in, because it doesn't change them. Does that make sense? No. So let's say I pass in, I'm going to call this min. Say I pass in 1 and 3 to min. So A is 1 and B is 3. If 1 is greater than B, nope. And we skip to return A. We return 1, right? What happens if I swap, if I have, let's say I have 2 and 5 and 2. So A is 5 and B is 2. What happens now? Yeah, it returns 2. Like I actually swapped A and B, so this A gets passed into this. So the function, the variables local to the min function get changed, altered, but nothing outside of it. Like this doesn't change the, like let's say if this was in my main, it doesn't change the values in here. It only changes the values in this function, but it doesn't really matter because they're going to go off and die anyways. So nothing in the outside world gets really changed. The only thing I do is return the minimum of these two integers. So it's cool. So I guess we're done with that example. So go on to
Right. Here I have a function, string. It returns a string. It's named reverse. It accepts a string as an argument. What it does is it takes a string in, reverses it, and returns it to wherever it was called. Okay. You have three variables: temp, I, and j. I is initialized to 0. J is initialized to s.size minus 1. S.size returns the length of string s. Remember. And our condition is while I is less than j. We're going to do something, and then we're going to return s, and it's going to be reversed. My question for you is, what goes here?
I guess
I'll give you guys 4 minutes to work on it. right, you guys can continue working if you'd like, but I'm gonna go over the solution to this. Alright, so we have several pieces of information. I'm gonna draw an example piece of text for you guys to kind of trace through this with. We're gonna use the word hello. Hello. There we go. I want that more blocky. Sorry about that. Alright, so in memory, our string looks something like this. Okay, that's the termination character. Wait, what is it? No, sorry. That's wrong. Totally wrong. Different class. I apologize. Okay. Hello. Just keeping it simple. Alright. So, how many characters long is this string? What's the length of it? 5. Okay. So, and then I'm going to draw the indices on it as well. So, 0, 1, 2, 3, and 4. Okay. We have our local variables temp. We have I. We have j. Okay. In addition, we have their initial values. So I is initialized to 0. Okay. J is initialized to the length of this string minus 1, which you guys told me the length was 5. So 5 minus 1 is 4. Alright? And temp doesn't get initialized to anything currently. We'll use it later. Alright? So what is the goal? Our goal is to reverse the string. Well, how are we going to do this? Well, we have the beginning and the end. Okay? So we're going to start with this. We're going to take the first character and put it at the end. Take the ending character, put it in the beginning. Okay? And then after that, we're going to do it for the set of inner characters. So we're going to switch E and L, and then L with itself, or you can quit there. This works for even and odd length strings. So if I had this swapping H and T and S and H and I will give me a reversed this. All right. So let's walk through it. Okay. So what should we do? We should use what we have. We have I and J. Okay. We have the index of the first and the last character. So what we're going to do is we're going to swap them. So we need that temporary variable. So we're going to take temp and give it the value of, let's say, the index j. Okay, so the fifth character, index 4, is lowercase o. Alright, so temp is going to be o. Right? And then what we're going to do next is we're going to make this location, we're going to take this location and make it equal to the very first character, because we're holding on to this one, and we don't care what happens to it because we remember it now. And so we're going to put the first one located at I in the fourth place, located at J. So actually that one's still H. This is H now. Okay? And then to fix this, we're going to take our temporary variable and put it at the beginning. Okay? So now it's O. And we're on our way to a reverse string. So what should we do next? We know that I is this location right here. Okay? I is that index. J is this index right here, the very last one. Which next two elements do we need to swap? What are the indices? 1 and 3, exactly. So if we have one that is the location of our left index, and we have the location of our right index, and we know that we want to swap those, what should we do? What should we do to I and J so that we get 1 and 3 on the next go?
I plus J minus 1.
There you go. So we're going to take I, make it the next index, which is I plus plus. So now we have 1. And now it's the index of the second character, index 1. Right? J minus minus, that will give us 3. Right? And now it's index 3. All right. Okay. We have our condition here still that was given. So I less than j, this is still true. Do it again. Okay. So this we're gonna store the one here. So we're going to store the character at index j. Okay. So we have L. Then we're going to take the character at index I and put it where where index j is. Okay. So now it's E. Okay. And we're going to put the remembered character back where it was, or where the one that we just took from was. L. There we go. Right? And now to test our update action, because we knew it works just for that one case, we're going to do it again. So we're going to do I++, j minus minus, and see if it still holds true for this iteration. Okay? That's when we know that we've got it. It works a few times. Should work for pretty much all cases. So I++, we get 2. J minus minus, we get 2. Yes. All right. So we go to our condition, which is I is less than j. What does this what does the expression I is less than j evaluate to? True or false?
False.
False. Exactly. So we're done according to what we've written. And is that true? Have we reversed the string? Yes, we have. So we're done. We get to return the string. So the code for that, in short, well, it's a few lines, 5-ish. Okay. We have temp equals s dot at, and then it'd be j. Okay. S dot at j equals s dot at I. Okay. S dot at I equals temp. Okay. And then we're going to do I plus plus and j minus minus. There we go. You all understand what I plus plus and j minus minus are, right? It just add 1 to I and take 1 away from j. Right. Any questions? No? All right. I hand it off to you.
Alright, so this is a function that takes in a string.
Okay, no worries.
So this takes in a string, and then it has a bool, and then it loops through comparing different parts of the string. And if this value is to not true, so these aren't equal, it sets b equal to false. And then it returns b. What are the values of a, b, c, and d at the end of this? So true or false? I'll give you 3 minutes.
So is there going to be 4 answers?
Yeah, 4 answers. So A, B, C, and D. What are the answers for each one?
And again, like what kind of answers would they be? So you know that the answers are some boolean, and what are the values that a boolean can be? So they can be 2 possible values, right? Just true and false.
Yeah.
So yes or no. So out of these 4 function calls, which one of these are true and which one of these are false?
does anyone still need this left-hand side here?
So does anybody have any of the answers yet? Okay, I'll give you another minute.
So a good strategy, a good strat for this one is to actually figure out what it's trying to do.
Yeah.
So to, notice a pattern and like, hey, I can just like say, yes, yes, no, no, whatever. It's possible for this one. It's good to follow functions a lot, but sometimes it can be a little bit too time consuming. So trying to figure out like a clever pattern might be a good way to save time.
All right. Well, I'll start going over the answer. But anybody figure out like what meow is going to evaluate to? False? Yeah, that is right. So let's start with that though. Okay, so it passes meow, and then so it gets here. What is the first iteration going to look at? Like what two characters meow? So yeah, so the first and last one. So I is going to be equal to 0. So when I is 0, it's going to look at s dot I, and what is this going to be? For meow.
2.
Yeah. Size minus 1, so 4 minus 1, so 3. So this evaluates to 3, so it's going to look at s dot at 0 and 3, so, 0 and 3, so here and here, and then it compares them, right? What does it do? So it finds out are these equal or not? They're not equal. So what does it do here? Yeah, so it says beta false. So what does it do next? Like what's the next iteration then? Yeah. So now I is equal to 1. What two characters is it looking at now? And O, right. So this is going to be 2. Yeah, so the second character. So at that point, what does it do? It's check comparing E and O. Yes, it's set to be equal to false again, which doesn't do anything. And then what's the next iteration? When I is at 2. So it goes on to compare E and O again, but this time, this is going to be 2, and this is going to be 1. So now they're like reversing which way they're looking at it. So now it's going to, of course, be the same thing. So B is equal to false. And then when I is equal to 3, so this is going to be what? Yeah, 0, and that's going to be, right. So it's going to compare M and W, right? And then it's going to be false. And then I is going to be 4, what happens? Yeah, it breaks out because now this condition is not true because s dot size is 4 and I is 4, so I is not strictly less than 4.
Well, I'm thinking the idea is if the word is start the same both directions.
Mm.
But what would happen if you had a word like seed? Because when you got to the two middle characters, that would be true for a second. So then B wouldn't be false,
Well,
and then it would return true, but it wouldn't.
when would B be true? Or how would B be like? Or are you saying if it's
If you had a word
just
like
C?
SEED, so the two middle letters, when it evaluated those,
Well,
they would
B is set equal to false on the first one and the last one. But even if it wasn't reset to false, when does it ever get set to true again? So is there any way with this code, if this is run, for B to be true?
Well, couldn't it, well, if the first and the last letter were correct, then it would go B is,
Yeah, but it doesn't
so it's always
check that.
false.
Yeah, so if it's ever set to false, in this, there's no way it's going to be true. Does that make sense?
So if in any case it's false, it would do.
Yep. So yeah.
Cool.
Wait. So now let's try race color. Only do the first two.
Yeah.
Okay, so we start with I equal to 0, right? So I is equal to 0. What two characters is it comparing? Yeah, R and R. So this one and this one, right?
Mm-hmm.
And then that compares to true, so it does not run this code. And then at the next step, right? So what two letters? Yeah. So still true. So the next one? Yeah. And then the next one? Well, what happens? So now I is going to be equal to 3, right? So when I is equal to 3, what happens with this? So it's s dot at 3, and then what is this going to compare to? Yeah, so it's of course going to be the same because they're the same character, right? Yeah, and then it's going to go through, and then on the opposite side it keeps checking, and it can just recompares them all, right? So after it goes through, it's going to be true. Do you have any ideas what this does? Yeah, the same backwards and forward are also called a palindrome. Right? Any questions on how this works?
So you just keep going until the for loop is false, right?
Well, no, you just keep going, you just keep going until this condition is false. So when I becomes equal to or greater than size.
And then the output is whatever it was before it became false.
Yeah, or whatever it was after
Before,
this. So like whatever it was, that's what it returns. So if this line of code's ever run, it's false. Any other questions? Right.
So you can say, what are C and D then?
Yeah.
True, false.
Yeah.
So top of cat reads the same forwards and backwards. Function doesn't. So.
Right.
Alright, cool. Alright, so we're gonna be moving on.
Is anybody still copying it?
Okay, cool. So we're gonna be moving on from. What was it? I don't know. We're gonna focus more on vectors, the latest thing that you guys learned, and the last concept you guys are gonna need for the test. So first off, what's a vector? Yeah, so it's just like some way, like how do I store like a bunch of data, a bunch of variables? This is a way to like store a bunch of variables in one name. So it's almost similar to like a string. A string is kind of like a vector for what? Yeah, it's kind of like a vector for characters, except that this is a little bit more general, and this vector can pretty much like consume everything. I like to think about like these are like alligators that are eating something, so like this vector consumes strings. This vector can only hold strings, and we store it under the name v, and I can access it using almost like a string. So I can use the add functions, and I can ask it its size using dot size. So, but there's a few differences. So first off, how do I like insert stuff into a vector?
Pushback.
Yeah, I use pushback. So I just say pushback, and where does that add the vector, the element to? At the end. So my vector right here becomes pi. After this puts this string back to the end. So this vector v becomes what?
One second before you add to it.
Oh, so it's actually empty before I add to it.
But
So
if it was an integer vector, would it be zeros?
it'll still be empty.
I thought he said something.
Oh, so like, so what he's saying is
I
this
thought
is.
he said it had zeros in it, when it was.
So if I have a vector of integers, and if I give a default size, let's say 3,
Then it would have.
it's gonna have it's gonna be a vector of integers with 3 elements, and those elements are gonna be 0.
Okay,
Because
so that's the only time that it fits it, otherwise it would be.
yeah. So and for string, it defaults to the empty string. But like if I initialize my vector this way, so it's gonna have nothing in it initially. And then I push back high, and then what happens when I push back there? Which position does there end up being in? At the end. So high, there, and then world, etc. So my question is, what is the output of this following code snippet? So give it this, so pretend this is into my main, and if this runs, what is output at the end? So I'll give you guys like about 30 seconds. You don't have to, if you're writing this down, you probably don't have to put the long strings I put. Hi there, world, meow, and some like cat face. Two, one. Okay, so what is the actual output of this code segment? Yeah. So I call pushback. I have hi there world. I call this function empty, meow cat face, and then I print out each element because I say for every element to my array, print it out. So what happens? Yeah. So what happens when I call this? Yeah. I mean, so let's just say that if this function empties the vector, the only thing that should be print out is what? Meow. But that's assuming if this empties the vector. This doesn't actually empty the vector. What does empty do?
Does it remove the last one?
So this is a hint. V.empty isn't a void function. It returns something. What does it return?
Oh, there's not.
Yeah. So this is just asking, is the vector empty? Notice that this is a function that actually modifies the vector. It just says like, hey, are you empty? It's the same thing as checking if the size is 0. So this actually does nothing right now. So I don't assign it to anything. I don't check it for anything. It just like says, are you empty? Cool story. Yeah. So what's the actual output for this code? Yeah, it's just it's going to print out every single element of my vector in the same in order, one at a time. It's going to be hi there world exclamation meow exclamation cat face. And all in a separate line. So like bam, bam, etc. Okay, so what if I have this? what is the output of this code step? Yeah, just meow. So like, this is the function that I guess you were looking for. So empty, well, empty just is a check. It's a predicate saying like, hey, are you empty? This is the thing that actually does this one is the one that actually does the action. It just like destroys everything. So everything in my vector is actually empty. My entire vector is empty, and my size is now 0. And why this prints out meow is because after I clear out this vector, I actually add an element to it. I add meow, and that's the output. And so what about if I do v.pushback? Let's do v.pushback right here. Let's do popback. What's going to be the output of this program? Yeah, hi there meow, because my vector is hi there world at this point. And what does popback do? Yeah, it destroys, it removes the last element of my vector. So that's world. And then after that, I immediately put in my meow. So like, meow, whatever. And that's my vector, and this prints out hi there meow. So any questions? So again, this is just, good question. Oh, so what are the main methods for a vector?
What?
So can you guys give me like 5 methods for a vector? So I pretty much use all of them in this example.
Oh,
Yeah, pushback, popback.
size.
Yeah, size, almost like string. Adds. And then again, I use v.empty, which is a predicate, and v.clear, which is a procedure. Okay, cool. So I'm gonna take it on to give it to Michael.
Can I get a green?
I have a quick question. So does v.empty, does it return anything? Like a true or false?
It returns a boolean. So like I can say if not v.empty, cout Alex is cold. It's going to check, hey, is the vector empty? And at this point, is the vector empty? No, it's not. The vector has some elements in it, and it's going to print out, hey, Alex is cool. So to speak the truth, basically. So, yeah, this returns a boolean. I can use it like this.
Now we're going to go over 2D vectors. You've seen vectors. They have this format. They're form vector. Then you got that left angle bracket, and then you have a type. You got the right angle bracket, and then you have your variable name. Okay. Type can be any type, even a vector. Okay. So a vector is a type, and you can specify it as a type for a vector. So a 2D vector is a vector of vectors. Okay. So right here we have vector, and then this is our type. This is our variable name. Okay. Inside that we have our type being a vector of integers. Okay. I have a question for you, 2 of them actually. What is the type of this expression, and what is the type of this expression? So those are both syntactically correct. Give you guys a few seconds. Whenever you have an answer, you can raise your hand. We'll do this one first, and then the next one. Yes. Yes. Vector of what? Yes. All right. What's the next one? Just an integer. And why is that? Well, when we say dot at, we get element number, whatever we specify in the parentheses, and it returns that element, okay? Every single element inside of a vector is of the type specified. So if you have a vector of integers, every single element in a vector of integers is an integer, okay? So if you have a vector of vectors, at the top level, every single element is a vector, okay? So v dot at 0 returns a vector of integers, okay? Then on top of this, we can specify, so this boils down to a vector of integers, okay? And on top of this, we can specify the dot at member function of a vector, because it's still a vector. It still has its own member functions and data. So we say dot at 0, okay? And this is the order in which it operates, or evaluates. So it does the one closest to the variable name first, and then it does the one after this one gets evaluated, okay? You don't need the parentheses, but you can have them. You probably shouldn't put them though, because extra typing, you don't need it. So v dot at 0 returns what? First spot, which is vector of integers, right? So it's a vector of integers. Dot at 0 returns whatever is the first integer, okay? So knowing that, I would like to go over this code a little bit. Assuming that inner, because I didn't want to write the code to actually initialize that for you guys. Assuming that it has a whole bunch of strings, and the first string is called string, or it has A in it, the next string has B, C, so on. And there's 5 of them, so the first one's going to have A, the last one's going to have E, okay? Well, first of all, what are the contents of V? And secondly, write a for loop to print out all of the strings onto the screen. Yeah. I'll give you guys 3-4 minutes. You're going to, how about you just write the for loop first? Write a loop to print all of the strings contained in V.
You can do this either using, you can just write a function, or you can write code that prints out all the elements of that.
Okay. So I'm going to give you some sample data. It's not shown here what inner is initialized to. I'm just going to give you some data. So we're going to say that inner, remember it's a vector of strings, so it's just a collection of strings. All right. Inner is equal to A, B, etc. all the way through E, because there's 5 of them. All right, so 5 strings. First one's A, the next one's B, all the way through E. A, B, C, D, E. Okay. Now we have a vector of strings. Okay, so when we call pushback, when we call dot at, all those things, we're interacting with whatever type is specified. Okay, so if we call b dot at and then we ask for the first element, index 0, then it's going to return an element of type vector of strings. Similarly, if we want to push something onto this vector, right? If we want to say pushback and then give a value, that value has to be of a certain type. That type has to match whatever type the vector is, and it's a vector of strings. So whatever we push onto B has to be a vector of strings. Okay? So it's going to do it 5 times. You're going to push back inner, right? What is inner? Inner is our vector of strings. Okay? And it's going to push it back 5 times. So the first time, it's going to push back, so b dot at 0, right? So the very first element is going to be equal to inner, which you can see here is a, b through e. Okay. The next element it's going to push back is element indexed by 1. Okay, so the second element, b dot at 1 is equal to inner, and so on and so forth, all the way through index for element number 5. Okay. So we need to write a for loop to print all of these strings. Okay. And we want to print them in order. Okay. So if you think of inner as going left to right, okay, and pushing back, calling pushback will push data this way, so 0, 1, 2, 3, etc. Then what we should end up with is kind of a matrix, or a 2D array, basically, or 2D vector, sorry. It has 2 dimensions. It's got an x direction and a y direction. That means it goes sideways and it goes up and down. And it should look like A, B, all the way through to E, okay? And then downwards it should be A, E, and this should be the number of times that we pushed it back, which was 5. So 0, 1, 2, 3, 4. These are indices. Okay. So we're going to write a for loop. That's what I would start out with. Okay. And what do we want? Well, we want to deal with the very first element. So we can start off by going over every single element in B, which they're all vectors of strings. So we're going to write some code to get every single vector of strings. Okay, so we're going to start at int I equals 0. I is less than b dot size I plus plus. Okay, so this will give us every single time this loop runs, it's going to give us a vector of strings to work with, right? So we've just broken down the problem into a smaller piece, because this is kind of hard to think of if you're new to it. So what we've done is we're going to go through a vector of strings every single time. And now that we're at the vector of strings level, we know how to use every single one of those. So what do we do with a vector of strings? Well, we want to go through that and get every single string out of that. So we're going to iterate through, starting at 0. So all the way through less than size, we're going to go through every single element. So for int j equals 0, j is less than b dot at 0. Sorry, I forgot to explain that. Dot size. Plus j. Okay, I'm going to erase just these indices that I wrote here. Okay, so they don't run into each other. All right, what is this doing here? Forgot to talk about the dot out part. So imagine this. Each element is itself a vector of strings, okay? So when we say v dot at 0, we're getting a vector of strings. So v dot at 0, or wow, I shouldn't have done that. I said 0, I meant to say I, okay? Because it's supposed to move with us. Yeah, sorry about that. V dot at I. Why? Because we want this first row. Okay, so we've got the first row, and we want to go through each element in that row and print it. Okay, so the first row is the expression v dot at I, and for the first iteration I is 0, and I will increment, and you'll go through every single row. Okay, so the first row is A through E. Okay, and we're going to go through A through E and print every single one of them individually. Okay, so you can mentally replace v dot at I with this is the current row I'm working on. Okay, and then that row has a length as well, right? So it has a width, and we need to recognize that. So it's going to do it the number of columns that there are in this part right here. So what are we doing? We are going through every single row, and on every single row, we're going to print every single column. Okay, so our action is cout. We're going to do v dot at I, because that's the row that we're working on. What's the expression using v dot at I? What's the expression for the row, or no, the column that we're working on? At j, yes. So append dot at j. Okay? So v dot at I gives us our current row, and then dot at j gives us the column within that row. All right? We're going to print that. So this returns what? What type does this return? String. Yes, it returns a string. Okay? So returns a string. We're going to print that string, and then we're going to maybe add in a space here so that it doesn't run into the other string. But we're not going to put a new line yet because we want it to print a new line at each new row, right? If I'm going to print a new line, I should add a brace here. Okay. Right? And so I didn't use braces here, so after that statement, that for loop is over. Okay? So I'm going to go down here and say out a new line, and we're good. Okay, so to recap, what do? We go through every single row. For every single row, we go through every single column and print those elements one by one. Okay? At the end of each element, so each element has a space after it, and then once you're done with all the columns in a row, then you print a new line and you do it again, all the way through every single row. Any questions? No? All right. Cool. Hand it off to you.
So actually, we're going to take a small kind of break, and we're going to ask you guys if you have any questions. So again, like I kind of promised, this will be more Q&A. So do you guys have immediate questions you guys want to get off before the final? Yeah.
Is the final all multiple choice, or do we have to write out code?
It can be all multiple choice, but it's going to help a lot to understand and be able to write code, which is why we're having you guys do that.
Do you know approximately how many questions?
A lot.
35.
About 35.
I could barely do 18 in 50 minutes last time.
Yeah, 3 hours.
So yeah, based on that math, you should be able to do it.
I should be able to.
Yes.
All right, so we're actually not done yet.
Okay.
So we're gonna be doing some more questions. If you, we're gonna be doing some more problems if you guys don't have any questions. So just saying. Yeah.
These are great problems.
Are clear and empty good for testing?
Yeah, definitely. So like, was it Chris brought up? He specifically brought up those methods. In addition to pushback, popback, he also talked about empty and clear in one lecture. Yeah.
You mentioned there were 2 questions about like if you don't initialize an integer or something, like what is it going to be? Are there going to be more questions like that in the C?
I can't say for sure, but possibly. Do you have any questions about that right now?
Yeah, I mean you just explained then in each in an int, in a character, and so on what happens if you don't initialize them.
types you guys use. With the exception of vector and string, if I don't like actually initialize it with some value, we don't know what value it's going to start with. So that's like, we call those junk values. The initial value is unclear. So if I have integer I, we actually, if I print out I,
We did that error.
it does compile. It's just that it's going to print out some junk values. So if I say, oh, it's going to print out like 2 billion something something, why did it do that? Why is my program broken? Is our stuff broken? I'm just kidding. It doesn't, so we don't know what value it's going to have. That's why we should initialize it. So like, it's I equals 0. We know for certain that this is going to print out 0. And again, this holds for double. This holds for chars, doubles, double. But what type doesn't? What type does it not hold for? What type do we actually know the value when we initialize it, when we declare it? Not Boolean. Boolean actually no. It can be true. It can be true or false. So int, char, double, and Boolean are what we call primitive data types. There's a few special data types which actually we know the value immediately. Yeah, of any vector, we know that it's going to be an empty vector if we don't initialize it to anything. And something else. Yeah, string. So let's have a string. Say string I. String I, this is going to print out the empty string, so pretty much nothing. So a string is always going to be initialized to the empty string if we don't give it some initial value. And vector is also a special data type in which it's going to just have nothing, no value, when we initialize it. So any more questions?
Because on the midterm, it was actually very specific on the range of values.
Yeah.
I don't remember if there was an option for like junk.
Wasn't like 2 billion?
Yeah, so you're not going to have to remember specific values. Like, you know, he put like, 2 billion something something, right? You have to know it's about 2 billion. It's about something we call 2 gig, which is around 2 to the 31. You don't need to know this exact number, but integers can go from minus 2 to the 31-ish, all the way up to 2 to 31, which is about 2 billion. To minus 2 billion. That's all you need to know. So it can be anywhere within that range. Yeah.
Integer vectors start with 0.
Yeah, so like if I have, as we were talking about earlier, let's say I have an integer vector, int, let's say, we're making an integer vector of size 3, but we didn't specify the values of those integers. So it's going to assume like, hey, we're going to give you 3 zeros, have a cookie or something. So that's what it defaults to. That's the only time where it defaults to some value, when I initialize the vector to some size and I give it some integers. And for strings, it's going to have like a bunch of empty strings. Doubles is going to be 0.0. I don't think I have to worry about chars. Chars is going to be the null string, which is also 0. So what if I have this parameter? He went through this like very quickly. What does that second parameter do? So this parameter denotes a size, the default size. This parameter denotes the default value. So I'm gonna have a vector of, I'm gonna have 3 2's. And you can think that by default this is 0. So that's what happens. So any more questions? Or do you guys want us to get back to forms? Yeah?
Are SPRs ever global?
SRAN. So SRAN is not really global because it's a function. It needs to be called somewhere. So it's usually called in main, seeded in main, so that any function that uses ran is already seeded. So like SRAN is not called in the global namespace because that doesn't make sense because like functions can't really be called outside of a function. Yeah.
Can you explain what exactly SRAN does?
Oh, SRAN. So SRAN takes in some integer. What does SRAN stand for first of all? Yeah, it's seed ran. It's going to seed the number, random number generator, so that every time I seed it, it's going to give me a different list of values. So if I seed it with the value 2, it's going to give me a different. So ran is going to give me a different value. So if I call ran, it's going to be 2, I guess. But I call ran again, it's going to give me like 4 million or something. I don't know, some crazy number. But let's say if I seed it with 3. It's going to give me completely different numbers. So like, I don't know, 5, 5, 5. So it's going to give me a list of completely different numbers. And we usually see this as what? So we see this with another function, right? Time? Yeah, time. So we just seed it with like the current time. So that's it's almost always different each time we call it. So that's SRAN in a nutshell. So any other quick questions? Yeah.
Can you put a declared vector inside another vector?
Declare a vector. Yeah.
Yeah.
So you mean like
you declare a vector and then you put it in that vector in another vector?
Yeah, that's what Michael did in this previous example. He declared a vector and like he was pushing back vectors. So I guess we already showed you an example. Did you have any notes?
No, I'm talking about like if you first declare this vector,
yeah,
and then you declare another vector, but you put that vector inside.
You can do that, but you probably don't like. It's probably not gonna be an issue because that's a little bit too crazy.
Okay.
But you can totally do that though.
Okay. And what's the difference between like ++I and I++?
The difference you don't really need to know this, but like.
Yeah, he said he wouldn't get technical on that.
Huh?
He explained it, but he said he wouldn't.
Yeah, he wouldn't test. It's not really important, but like. This happens after the statement, like the actual increment happens after the statement. So if I do something else, yeah, it doesn't really matter at this point. So I'm gonna go through one last example. So it's been a while since you guys done anything complex with booleans, with conditionals. So this looks very scary, right? So it's not that scary when I first break it up. But my first question I'm going to ask you is, remember De Morgan's law? So remember De Morgan's law, when I have a negation in front of conditional, it changes, it negates all the operators and all the operands, right, of that conditional. So if I have not A or B, this becomes not A and not B, right? And the same thing for, let's say if I have or, let's say if I have and. What is this equivalent to? Not A and B? What is that equivalent to? It's actually not A or not B.
Okay, so the first one's equivalent to the second one, the third one's equivalent
Yeah.
to the fourth.
So these two are equivalents, these two are equivalents. So the question becomes, given that these values are initialized to this, A is equal to true, B is equal to false, C is equal to false, and then num is equal to 3, tum is equal to 5, yum is equal to 77, bum is equal to 99. What is the result? What's the statement I get when I apply De Morgan's law? And also, what does this expression resolve to? Does it resolve to true or to false?
So you can change the inner squares and then the outer?
Yeah, you're going to want to, like, that out affects everything within the parentheses.
Yeah.
So
you work from inner to outer?
yeah, you go from, I guess, outer to inner. So this not is going to apply to here, which is going to apply it to each of these operands.
So you wouldn't do it after you change all the
Like
the
you,
inner stuff?
you would actually just apply the not over. You would apply the knots into these parentheses, which would apply it to these two operators. Flip this operand, and apply it within these. It goes deeper inside, so it goes from outside to inner. Does that kind of make sense? Yeah, it just goes deeper. And so, one question: what's the logical opposite of the condition of the greater than and equal to, greater than equal to, less than? Like, so if I have greater than, what is the logical opposite of this?
Listen.
Less than or equal to. Not less than, it's less than or equal to. Because if it's equal to something, like let's say A is greater than or equal to B, the exact opposite is A is less than or equal to B. Because this doesn't include equal to.
And then vice versa.
And then vice versa. The logical opposite of this is this. And logical opposite of, let's say, less than is what? Yeah, greater than or equal to. It's probably a good idea to break it apart. Something scarier appeared on a final once, my final. It's really good to decompose this, like scary, into all those parentheses. Okay, I guess I'll start now. So again, De Morgan's law says that
Morgan's law?
De Morgan's law. So De Morgan. De Morgan. Like, I'm not sure what starts with De. What does that mean, Dylan?
Yes.
So this nos, this negation operator, gets distributed to this entire expression. So let's just take it one step at a time. So this not goes from here and gets applied to not this, flips this operator, this becomes or, and applies the not over here. So so that's the first step. Since we can just like make this A, and we can make this B. And then we flip the operator, and we just said, okay, not A, not B. Not A or not B. Just using that. Right? So that's the first step.
It's just like a rule, you just don't see that you do that, because I can't logically make that work in my head, so that's just a rule. Like
So-
if you see the not outside the or, you just separate there.
I mean, it's just a variable substitution. All I'm just saying is, okay, this big scary block, I'm gonna call this A real quick.
No, it's fine, I'm not
And I'm gonna flip this operator like that rule says. And then I'm gonna call this chunk B, right? And I just say not B.
And B all goes all the way down to the end, right?
It goes all the way down to the green parentheses. So that's the first step. And then we apply it again, right? So I'm gonna distribute this across this entire thing. I'm gonna say this is my A. I'm gonna flip this. What does this become? This OR. And then this, I'm gonna say that this is my B. And what does this become? Not, whatever this is. So this is not B. Yeah.
Can't you just have kept everything and then just work your way from the inside out?
You can do that and then negate at the end. But he may ask you for like, hey, what's an equivalent expression to this? And you can use the Morgan's law to like distribute the knots and like create other equivalent Boolean expressions. So that's why I'm just trying to combine these two types of answers. Like you can say, what does this expression result? What does this expression result to? Or what's an equivalent expression?
So now you would change it to and an exclamation point.
Yeah.
So you're just working on that.
So I'm just working on this side, and then like I'm just gonna keep on going in until like I can do something. And actually, I can do something right here. I can notice that like I have two knots. So what does not mean? It just means a normal expression, right? So two knots cancel each other out as a double negative. So I can just like pretend this never happened, and I can just have this right here, right? And yeah, I can just like ignore that. I can just take away that knot I have right there. And but now I need to distribute this this knot inside of here, right? So what does this become? So remember that. Let's say that now we can just say like, okay, this single variable A is my A and this is my B. What remember my rule is not A and then flip the operand and not B or not. So this becomes what?
Not A or.
So I distribute this in not A or not B, or not B, little b. And again, double negation, so we can just like cancel these two out. So we're pretty much done distributing that knot there. And so I'm gonna go a little bit faster, and we're done distributing the knot here. So now it's this side. So I distribute the knots over here and over here while I flip the operator. So double negation, what happens? Cancel out. And then I have num plus bum is greater than yum. What happens here? Remember my rule? Yeah, this becomes less than or what? Equal to yum. And so that's done. So actually I have no knots now, except this one. Yes. But that one's pretty easy. So now I can actually use this information to like determine what the value is. So since so not A, what is that? So if A is true, what is not A? False. So I have F or B, and if B is false, then this entire expression is what? False. So I'm going to erase it. False. False, and we can actually use short circuit. We can use short circuit analysis. What is this? What does that say? So since this side is already false, and we have the AND operator, this is already false. We don't even need to bother to look at this. So this is false. Did everyone see why? Because like for AND, both operands need to be true. If we already discovered that one operand is false, we can say the entire thing is false. So now we have false or in this mess. So is num greater or equal to tum? When we look at this right here. Yeah, just kidding. So this is 3 and this is 5. That's false. And the whole thing's false. And so like we can just compute this for duals. So like this is going to be 82 is less than or equal to yum. And that's true, but we don't care. So this is something we're evaluate to true, but we don't care because this is already false. So false and true is equal to false. And now we're at false or false, and then we're at false. So the entire thing was false. Okay, so we're almost, I think we're out of time, right?
Yeah.
So any last minute questions? All right, thanks for coming.